Cảm ơn anh nhiều.
Xin không quan trọng cái vấn đề interview with prepare. Sure cái zoom của nó ready correct chưa?
Đúng rồi, correct. Em coi lại cái này thằng Nhân để ý.
Chưa em ngủ bởi vì về nhà để làm.
Để em coi cái này thêm một lần nữa.
Chuẩn bị đi. Không có mấy phút nữa.
Morning.
Oh, good morning, Jim. How are you doing?
How's yourself?
Good. Start of a new week.
Yeah. 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 Sorry. Just getting yeah. Oh, here I
Oh, nice.
am. Anyway. So, what's up this morning
Yeah, just
with you?
being ready to have this opportunity with you. And
Okay. Alrighty. Do you have any questions or do you need me to go back over any of the files that I looked at that we looked at last time?
yeah, I
The
think we
drawings.
went through some of the graphs, differential return loss and differential insertion loss, and some different, I guess, test sockets, right? We had like a bunch of different,
Mm-hmm.
yeah.
Yeah, do you need me to go through any of that again, or do you want to look at any of it again?
Yeah. If you have any new latest one or any challenges
Well,
we
I mean,
have.
I have more of them. I'm just more of trying to figure out what questions you may have about the job,
Mm-hmm.
and you know, uh, being able to do it.
Yeah, so much a
Uh,
lot of data sheets, and then we're trying to customize it to the customer's needs.
okay, but are you? I think we talked before that you don't do a lot of mechanical drawings, right?
Mhm.
In your function now,
Yeah,
or
but I did have experience with SolidWorks and AutoCAD, so I can read those mechanical drawings that you
different
have.
drawings,
Yeah.
fine. Okay, so it's just a matter of training what it is and what matters on each
Mhm.
drawing. Okay. Um, what do you describe yourself in one word?
One word, huh? Oh,
One word.
driven.
Pick a good one.
Yeah, driven,
Okay.
hardworking. Yeah.
Yeah. I got it. Got it. All right. Um, why do you think you would be a good candidate for this job?
That's a good one. Well, I'm a good problem solver. I like interfacing with customers. I love talking, traveling, actually. I like to be on my
Hmm.
feet. So I like to do always hands-on stuff. But yeah, I
Hmm.
also enjoy doing PowerPoint slides and presentation.
Hmm.
Mhm.
Okay. Are you looking to travel a lot, or
Yeah,
doesn't
I'm
matter?
comfortable traveling. I can travel.
Okay.
It looks like most of our customers are in the Bay Area, but I'm willing to
Yeah.
travel across domestic. Yeah.
Yeah. Okay. All right. Yeah, we don't do a lot of travel, maybe driving, but you'll probably be used to that
Yeah,
to some degree, as you said, mostly around the Bay Area.
true.
Trying to remember some of what we talked about, right? I have two other guys,
Mm,
and the third open position and a technician that works for me.
mm,
Um, the technician does most of the repairs.
mm.
It all really depends on the availability. His job is to support the apps engineers and whatever they need,
Oh, good.
whether that's going to customers directly, like, he'll go to NVIDIA on his own, he'll go to Marvell on his own at this point with the, comfortable enough and know the people and the product
Mm,
and has a relationship besides the apps engineer.
mm,
Depends on the level of detail.
mm,
If we're doing debug, you'd probably have to go
mm,
from that perspective. Most of the debug's going to be mechanical related
mm.
at this point. Um, the electrical comes in with understanding what an open is, what a short is, what the customer's telling
Mm.
you.
Yeah.
Some hands on, but most of what we can address is from a mechanical perspective, right? We
Mm.
can't. The only thing electrical is the spring probe,
Oh,
right?
right.
So
Mm.
so there's not a lot of adjustments or things that can be done from that perspective. Um, the presentation you've done a number of presentations and
Mm.
procedures. Okay.
Yes.
Anything you are allowed to share or can share as an
Um,
example? We do have an NDA with Cisco, if that if
Yeah,
that
we have
helps.
an NDA. But I do a lot of, SOPs and standard operating procedures. So yeah.
Okay. Yeah. Okay. I was just looking for some samples, if that was possible, to show or
Oh,
no.
I think I can't disclose.
Okay. 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 Yeah. Even if a little bit of something that you've done before. All right. Okay. All right. What are some of the challenges that you've had with the customers, and how did
Um,
you solve it?
yeah. I mean, there's always a customer that wants everything right now, right? And you don't
Mm-hmm.
always have the the answers right now or be able to fix it right now. So they can be irate if their system's down.
Mm-hmm.
So yeah, it's about communicating and setting expectation. We're working on it. We give them timelines and we keep them updated throughout the day.
Mm-hmm.
That's one of the challenges, and it can be different culture sometimes and different personalities, and so
Mm-hmm.
you want to build harmony and build rapport. So you try not to agitate the situation more than it is. So, but
Okay.
it's good to ask questions. So then you find what really their needs and what their time schedule is, and we
Okay.
try to best to meet their needs. Yeah.
Yeah, yeah, yeah. Personalities can get in the way, and everybody deals with the stress a different way or timelines and so
Yes.
on. But yeah, good that you mentioned the asking questions. You
Mm-hmm.
know, a lot of sometimes what they're complaining about isn't necessarily what the issue is,
Mm-hmm.
or that maybe they can't describe it very well.
Right.
Um, kind of a thing. So,
Yeah,
right.
sometimes you just have to
But
ask different questions, like pulling teeth,
yeah,
to try
yeah,
to get to the
yeah.
root cause.
To
Yeah.
some degree, yeah, they have a certain thing in their mind, and then but they were like, "Why are you asking me this? That doesn't matter." And I'm going, "Well, it does to us, and we need to do this. These are the things that we have to do." I tell people that sometimes you have to do something to rule it out.
Mm-hmm.
May not be likely, but let's make sure it's not that, right?
Right.
As much as it can be, and so on and so forth. Okay. Um, we talked before that you you deal primarily with the servers at a assembly subassembly level, so you're not dealing with the chips.
Mm-hmm.
The I guess we'll call it the main network processor
Mm-hmm.
and so on, or other chips individually. Um, what do you know about in your job? What do you get to know about the customer, about the customer, about the about the chip itself, as
Mm,
far as the requirements, or are you looking just at a network level?
yeah, mostly it's at the network level. But at Truth, I mean, we did work with a lot of PCB boards, so there's some chips that we had to replace sometimes where I had to take
Okay.
them out and
Okay.
resolder them.
Okay. All
Components.
right. All right. Yeah. So what I'm looking for is, yeah, with it, kind of what we talked about before is, we're testing just the chip itself,
Mm-hmm.
nothing else, right? I
Oh, okay.
mean, on the so we're looking at what the requirements are for specifically for the chip.
Mm-hmm.
That that being the package drawing. Again, back to the electrical requirements
Mm-hmm.
on the insertion loss and return loss and all of that,
Mm-hmm.
for determining our system, our solution. Excuse me.
Mm-hmm.
The the mechanical aspects can be difficult, especially dealing with a like a Cisco board, right?
Mm-hmm.
Because a lot of our sockets have to mount directly to the board.
Mm-hmm.
In some cases, it varies from application to application. Oh,
Mm-hmm.
sorry,
Mm-hmm.
cat
No worries.
sneaking in my
Mm-hmm.
in my office.
How many cats you have?
Too many, too many. Hey man, she went out. Go
Mm-hmm.
outside. Um, my wife takes care of ferals and other things, so
Nice.
ended up with too many.
Oh.
Are you a cat person?
I think I'm more of a dog person.
Okay,
Yeah.
yeah, yeah. Everybody's one or the other, right?
Yeah.
Yeah, I like dogs when they're my neighbors.
Mm. Not your own.
And sometimes as long as they're not barking too much.
Mm.
Um, anyway, some of the systems can be challenging, right? Like us, some of the boards that we have to mate to are pretty simple. You know, they're basically following what we give them,
Mm-hmm.
and there's not a lot of components or other things in the way. And then of course you have the like a server board where we have to mount to whatever's there.
Mm-hmm.
Right. So in the past, we've done some really weird projects for Cisco that we're trying to find the nearest hole
Oh.
because we have to mount, we have to physically mount, compression mount our sockets to the board. So, you get these weird spider looking framework designs and then you have to worry about the airflow and things like that. So I'm focusing that there's a lot more mechanical to the job than there is electrical. But I am hoping, that, you can bring some of your electrical expertise
Sure.
or knowledge to the group, to the job. So we'll see how that goes. As far as, can you describe what you do electrically or what you know electrically in your function?
Yeah, I mean, I've been troubleshooting a lot in the electrical world too. So, yeah, I can find where the shorts and where things are not continuous.
Okay. So you're primarily looking. So what how much do you work? Do you work with measurement equipment? Do you use any network analyzers, anything like that? Are you looking at signals?
Yeah. We
Okay.
yeah, spectrum analyzer, VNAs, oscilloscope a
Okay.
lot, multimeters.
Okay. So you use that stuff yourself?
Yeah.
Okay. Yeah. Not expecting you to do it a lot. I'm looking at, broader scope of capability and what else we could do, right?
Sure.
We do have and depending on what your interest was, we do have our electrical simulation group, right? So I don't know if electrical simulation is something you might be interested in doing yourself.
Oh, yeah.
Right. So that could be an offshoot, probably not a primary thing to do, for the job, but maybe, if you're interested enough and want to learn it, maybe you could do it and maybe be a backup.
Sure.
Or do it, or maybe that's something you want to do, and that's you can evolve into that position too. That's always a looking for where you go from, what, some people are always looking for where can they go from here, kind of a thing.
Sure.
And positions as well. Smiths offers a lot. We're a big, company with multiple divisions with a lot of them. Some of them are more electrical, some of them are mechanical, some of them have the good mix of both from that perspective.
Okay.
So why do you think you're the right candidate for this job?
Yeah, like I said, I'm driven. I like to problem solve. I really believe every problem has a solution. It just takes effort and time. And I like working, pretty independent and also team. I guess with this role, mostly I'll be independent, right?
Well, I mean, you'll have your own accounts, right? So that really depends on when how the team is just, I try to continue to do stuff with the group, right? I mean, the team is going into the office together.
Okay.
Right. Is primarily, I mean, with me or Cleavon or the other guys, everybody's got a different, different schedule, I'll call it, in their life, whether picking up kids or this or that. Right. So there's, from a team perspective, there's an account team. There's an account manager, an apps engineer, and a customer service person. Right. So there'll be that team, but again, right now where people are still trying to figure out how much they want to come back into the office now that we have an office again.
Oh, okay.
Which is only, a few months now, right? Or so now. So all that's being worked out. So, the team is just the group, right? And my staff meeting, right? We have a weekly staff meeting and sometimes we just chat and sometimes, about business and sometimes we don't. Right. So there's that part. There's always the, going out to lunch together and other things that we could do from that perspective. So that comes up. But yeah, I mean, I guess from the most part, you'll be, working with a lot of different people independently, right?
Right.
I mean, but yeah, I mean, you'll obviously initially I would expect that you and I working a lot
Yeah.
together in the office, right? As far as the training and so on, and we'll go from there. We talked about the disassembly of things, right? As far as that's concerned, you said your fine motor skills, you can use a pair of tweezers pretty easily.
Yeah.
So that's one of those things that you just have to try, right?
Okay.
I mean, it's almost it's a practice kind of thing, and there are certain tricks that we can show you just to make sure all the pins don't come out, right?
Oh, okay.
Right. You're trying to replace not one out of 10,000, so you gotta some of the plates, like the bottom plate that holds them in, you have to be careful taking it off, obviously, and tap and do a thing so that sometimes you get that stiction, and some other pins will come out. Sometimes pins will come out just naturally because they're making contact to the plate and stuff like that. So,
Right.
let's see.
So a little lab bench and like microscopes maybe because it might be small, right?
Yeah. We've got them in our office. We've got a couple of microscopes and a bench, and some of the work you do at the customer site. Depending on what they have. Other times you come back to the office, or potentially they. It's not unusual to have a customer ship it to us, whether it be your home or your office. We typically do to our homes, just because not everybody's always in the office. There's not somebody in the office every single day, right?
Okay.
And there may be challenges having it delivered. So, case by case. If you decide to work in the office all the time, then less of a problem for deliveries and so on.
Where is the
What
office? It's in Milpitas, right?
it's in Milpitas. It's off of Dixon Landing
Oh, okay. I know that place.
and 880. Yeah. We're if you know where there's like a Holiday Inn and a Staybridge Suites. There's like two little hotels just south on Dixon Landing. We're literally right there. There's a there's a smaller office. I think it's 3 or 4 buildings back over there by the hotel. What else? Can I tell you? What else? Is there anything you want to ask me?
Most of the meetings are on Teams, and is it like overseas sometimes, like with China? Or
It can be from where that's most of the meetings are on Teams. Some people like to chat on Teams. I'm only on Teams when there's a meeting because I'm controlling how people. I can have 5 different. I don't need 5 different distractions as far as how people are. As you saw earlier, I just got a text, so I don't get that many texts, so I was looking to see what it was and so on. So yeah, phone, email, text, Teams. It's up to you how you want what your best vehicle is. I've gotten complaints from some of my guys saying that we're always being bothered with people are chatting us and on Teams and stuff and like that. And I said, well, don't turn Teams on. I go, Teams is a meeting tool. Yes, you can chat on it, but you don't have, it's you have your work to do. So I'm not trying to dissuade communication. I'm trying to focus them.
Focus, yeah.
That's not an excuse for not getting your job done, right? Manage your work and so on. So, and the interface with others, right?
Yes.
Obviously, the customer orders and the customer communications come first, and then the internal stuff comes next.
Right.
As far as me as a boss, I'm here for whatever you need. I'll do everything, but but you're empowered to do what you need to do. Sorry. If you need me, I'm here. Okay. If you don't, that's fine too. I don't want to be a micromanager, because if I have to, then you're not the guy I want for the job. from that perspective. Let's see. I mean, all our benefits are standard. I talked about our company being sold, correct?
Oh, you did. Who's it being
Didn't
sold
I?
to?
Didn't I? I thought I mentioned that. I usually try to mention that like for one of the first things last time.
Oh,
Maybe I didn't say it, but well. So Smiths is they're selling the entire Interconnect division.
okay.
So we've been up for sale for a while now,
Mm-hmm.
but we're a pretty big company, so it's going to be a pretty big company. The only name that I know of is Molex.
Molex.
I don't know. I don't know if you know Molex or anyway, but anyway, the Smiths there's about 6 or 7 different product lines
Mm-hmm.
within the Interconnect division.
Mm-hmm.
So Smiths Group, which is a UK
Mm-hmm.
conglomerate, has decided they don't want the high tech volatile market.
Mm-hmm.
They want to stay with industrial stuff and so on. So they're trying to sell us. They're selling us as a whole. They're not trying to piece us out
Okay.
as different products. So that's why it'll be a larger. They're hoping to have the sale announced by the end of this year.
Okay.
Um, um,
So we'll all transfer to Molex.
we'll transfer to somebody,
Oh, okay.
right? I mean, there's there's companies like Molex looking at us,
Mm-hmm.
from what I hear, and then there's also venture capitalists looking at us.
Oh.
Okay, so we don't know, right? I'm just giving you expectation. So none of the people that I know of, right? So what they've told us is there's connector type businesses looking at it,
Mm-hmm.
like Molex,
Mm-hmm.
which is not our business, right? So we do have a connector business as part of Interconnect, which is similar to Molex, but the stuff that we work on is not. So from that perspective, we're an add-on, right?
Okay.
All right, as opposed to we do the same thing, right? So when you do the same thing, you get a little more worried about things coming together and and the issues that come up with that. But I've been through this like 6 times.
Oh, okay.
So I'm like, okay, we'll just here we go again, kind of a thing. So not a lot of worry from that perspective is my point from there. Okay.
Okay.
Let's see. We talked about presentations. I'm trying to think of what else. Travel. All right, give me a second. Let me get
Sure. No worries.
My wife's walking up. I just got to close my door. My wife's out.
Sure.
All right. Okay.
Yeah, no worries, Jim.
No problem. All right. Oh, she got it for me. She heard me.
Okay.
I could hear her. She could hear me. Let's see. You do lab views, SolidWorks. All right. So it looks like you have all the skills. Why do you want to move on from Cisco?
Yeah, I think I always wanted to be growing, and then it's good to kind of be diverse in my skill set. Now that I'm coming over here, maybe more stronger, skills in mechanical, hands-on, so that, when AI does take over, at least there's I can do a lot of things that that I'll still be stuck, I'll still be around.
Yeah. So I got it. Yeah, I get it. Yeah, everybody's talking about that.
Right.
I
So it's
said,
good
well,
to be.
hopefully we're not going to use it for, it seems like we're using it for dumb things,
Yeah.
right? Instead of smart things.
Right.
But more importantly, you have to know which cable to disconnect so AI doesn't take over the world, right? Okay, so in your it looks like you're relatively centric to the semiconductor industry, so you're wanting to stay there. Okay.
Yes.
All right. Let's see. I'm trying to think of what else I can do with you today. Because some of it I would want to. Would there be an opportunity for us to meet in the office?
Sure. Yeah.
At some point in time.
Yeah.
Okay. All right. Because I want to show you the product and maybe let you touch it, play with it, and see
When are you going to be in the Bay
Um,
Area?
I'll be in the office this week.
Okay.
Um, I'm gonna actually drive in as soon as we're done here.
Oh,
Next week I'll be in Texas, and then the following week I'll be back.
okay.
So it could be, doesn't necessarily have to be this week. And maybe what I'll do is I'll have my guys or have you set up conversations with my guys
Sure.
from that perspective.
Mm-hmm.
What I wanted to do. Um, let me get up. Let me go back to what I was showing you before.
Okay. Yeah, we can go.
And find the Cisco drawings here. A minute.
Mm-hmm. Sure.
Almost there. Just trying to pull up all the.
Are you sharing your screen? Or?
Not yet. Not yet. Just still trying to get everything
Sure.
together here. So in just a minute.
How long have you been in the test socket business? Or?
Oh, the test socket business is probably 1996.
Mm-hmm.
And then I worked at LSI Logic for 11 and a half years as a customer.
Mm-hmm. Okay.
There it is. Okay. Okay. I think I showed you a different may have shown you this drawing or not.
Mm-hmm.
Most of the drawings that we get are PDF. Uh, I think I showed you this one last time.
Mm-hmm.
Yeah,
Yes.
yeah, yeah. So anyway, this is actual, this is what I got in a DXF format.
Mm-hmm.
From the customer as opposed to PDF. Sometimes we get both, just because we'll have to take measurements or so on, or step files
Mm-hmm.
that we talked about before. So, for example, I'll get the step file, and if you notice, I'm using eDrawings,
Mm-hmm.
which is the SolidWorks. So most of the time, I use eDrawings just because it's simpler and easier than pulling up SolidWorks
Oh, okay.
native, but we do have SolidWorks on our laptops and so on. So again, just so we can look at it. So we talked before about this being the BGA,
Mm-hmm. Yeah.
the ball grid
balls.
array, or the solder ball side, and then this being the top side where you've got the actual, this is optical transceiver chip.
Mm-hmm.
So this is the silicon die with some components, and then there's a connector that gets mounted other components or a connector that gets mounted to this
Mm-hmm.
chip, but we're testing it in this form.
Okay.
So if I go back to this, so one of the things, do you understand what this dimension here means?
Was it like the diameter?
Okay. Well, let's see here.
Offset.
Yeah.
Oh, just like a
This is
tolerance.
right. So this is the diameter. Do you know what the symbols? You know what this symbol means?
I think that's the cross section or
Yeah, positional.
positional. Okay.
Okay, so this is positional tolerance
Mm-hmm.
um, of a diameter of 0.15 in
Mm-hmm.
relationship to datums C, A, and B.
Mm-hmm.
Okay,
Okay.
so I don't expect you to be a a GD&T geometric and expert. Just
Mm-hmm.
wondering. I'm just
Mm-hmm.
asking.
Okay.
So what you're to me it's a level of training, right? Right.
Mm-hmm.
So this being a diameter symbol, so this 0.3 millimeters is the diameter of the solder ball.
Oh,
You
okay.
can see here is here with its associated tolerance.
Mm-hmm.
Okay, and then and how about that symbol?
It's like a half dome.
Yeah,
So,
yeah, yeah. Okay,
or the height of it.
yeah, kind of. It's a kind of a flatness,
Okay.
coplanarity. So you have a height value here,
Oh yeah, yeah.
and then there's a tolerance to that height, or a flatness, but that includes any warpage in the PCB in
Mm-hmm.
the package substrate plus the ball,
Mm-hmm.
and then how about this one?
Not sure. Like some sort of parallel
Yeah,
separate
yeah,
layer.
okay, yeah, yeah. I mean, it's parallelism or flatness. So it's this is kind of like how flat is the bottom side, and this is kind of how flat is the top side.
Oh, okay.
But it's in parallel or in
Mm-hmm.
relationship to, because this gets the solder balls are flowed, and then the die itself gets reflowed onto the package, so
Mm-hmm.
it may not be flat, right?
Oh, okay.
Okay.
Might not be flat.
Yeah, yeah, yeah. So and and then here we've got the same tolerance,
Mm-hmm.
right? And this is kind of the bottom plane,
Mm-hmm.
right? This one being datum C, right? So this being datum A,
Mm-hmm.
this being datum B.
Datum B.
Okay, as far as the reference points for,
Mm-hmm.
like, this is D, A, and B, right?
Okay.
So this is the position. This is the position of these balls in relationship to the edge of the package.
Oh, I see.
Yeah, and
C A
then
and
to
B.
each other, to each other, right?
Mm-hmm.
So this is to the edge of the package, and then this is the position of the ball array, right? So you have the ball to ball position, and then
Mm-hmm.
you have the entire array in relationship to the edge of the package.
Oh, okay. To the edge of the patch. I
Yeah,
see.
a level of detail that we don't really need to get into.
Mm-hmm.
So I'm just asking, just to see how far, what you know, what you don't know, kind of a
Sure.
thing.
Sure.
Not a showstopper one way or the other, right?
Okay.
So this is kind of the flatness. So sometimes, like, this is the package body size, the
Mm-hmm.
size of
The
the package,
dimension. Mm-hmm.
custom, right?
Mm-hmm.
And then it doesn't have any definition of tolerance. Well, the flatness of the edge is the tolerance. So
Oh.
we can use this value
Mm-hmm.
as the tolerance for the
Mm-hmm.
package edge, and then based on that number, we decide if it's too big a number or too small a number for us to handle
Oh, okay.
in the package. So um, let's see. This here is the actual die size
Mm-hmm.
that we talked about in the other picture. So the
Mm-hmm.
size of this component.
Oh, okay.
This is where we're making thermal contact.
Mm-hmm.
So I guess I'm trying to, so the SR dam here
Mm-hmm.
is a solder resist dam. So it's kind of this border. I don't know if you can see it very well, but there's a border
Mm-hmm.
here
Okay, I see it.
around it. So
Mm-hmm.
that these things are just, so mechanically you just need to look at it and see, for example, we can push here, right, where there's no components and there's no other features that we need to separate or not touch, right? So a lot of times what I need to can you feel comfortable going from a 3D to a 2D?
Yeah.
Okay. So as long as you become familiar with, right? So if I take this and flip it, right, you can
See different
kind of get a
angles.
good. Yeah. I'm just trying to get you a position so you can see well, I guess that one's good enough. So you can see if you flip between the two, right? This is the die, and this is the die area, right?
Right.
From a translation perspective. Okay.
So
if this is the package size, right? Try to keep the 20.9 and 12.5 in your mind, right? And then we have the pit. This is the pitch. We call the pitch, right?
Spacing
the
between
distance
the balls.
Correct. There you go. And it's same on both axes. And then you have the ball diameter, 0.3. If you keep those kind of numbers in your head. I'm going to flip over. We'll look at the socket, right? And what I said is the socket fits in here, right? Okay. And the pins make contact to the ball.
Oh wow! Okay.
Okay. So, this being this is obviously the bill of material and some notes in the assembly of the socket. Right. I'll ask some basic questions. What screws, if you can read the item numbers, Eric? What
7? Is that the screw number?
Yeah. That's 7's a screw. How about? Yeah. I mean, I'll let you look at it. And then
5.
What are they? Okay. Anything else?
6.
Okay. And then what does 6 do?
I think it holds that plate number 1. And holds it to number 2.
Okay. And then what does screw number 7 do?
Oh yeah, 7 kind of holds that little plate number 3 in place.
2. It holds it to what?
Oh, it holds it to number 1. So number 3.
Okay.
That little screw number 7 holds number 3 to number 1.
Okay. Good. And then what does screw number 5 do?
Screw number 5. That one holds it all together, all the way down to plate 4.
Right. And plate 4 you could call the PCB.
Yeah.
It's just a bottom cover in this case for shipping and storage and stuff, but essentially it's PCB. Okay, well, that's fine. You got what you got what I wanted, which is you understand that an exploded view is how we assemble right items. Where are these? Where do these go?
Oh wow, those are probably the pin right in the center where it contacts the chip, right?
Where does it go in the assembly here?
Oh wow, huh? Probably goes right all in that middle rectangular space, that open.
Okay. So what I'm getting at is it says detail A here.
Detail A.
See where it says
yeah. I see the A on the left.
So you see
that little A.
So essentially, item 1, the pins are installed into item 1, and item 3 holds them in place.
Oh, okay.
So, all right. So we would assemble it this way, right?
I see.
We would mount this piece to this piece. We'd flip it over. We'd install all the pins. Then we'd install item 3 and then put the screw. So you see the screws for item 7, right? here.
Oh, okay.
They're larger, right?
Mm-hmm.
So you got you can kind of see the screws coming through here,
Mm-hmm.
right? And then you have the screw here, and then you have the screw here. This is a larger screw than this screw,
Mm-hmm.
right?
Okay.
So you can kind of see this is a larger screw, this is a smaller screw. So that this is where I'm looking for translate. You can look at this picture and translate it to this picture, right?
Right.
So these screws mount these two pieces, as you said. Then we install the pins, we put this plate on, and then we have these 4 screws here
Right.
that put it together. And then there's some guide pins and other things that are already pre-assembled into the frame here that you're seeing.
Okay.
Okay. So thinking back to the package drawing
Mm-hmm. Sure.
and the dimensions and stuff that I talked about, package size, ball diameter, pitch, right? What gonna zoom in a little just to make it maybe a little easier for you on your side. What dimensions on this drawing are associated with the package size?
Let me see the 12.6. Wasn't that the
Okay.
flip back to the other one? Was it 12.6?
Sure, no problem.
It's in that
Yeah,
circular.
yeah.
Yeah.
12.5.
Yeah. So the
20
12.6 and then 20.9.
Okay. Yeah. All right. All right. And then so part of it is what's the other dimension that we care about
Probably the
related
22.
to package budget?
Probably the
22.
22.
The
Or
22 where?
the left side.
You said 12.6.
Yeah,
Okay.
12.6. I got that one. And then, oh, yeah, the 21.
Okay.
Yeah,
Okay.
there we
Okay. 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 So yeah. So what I said was this is where the package sits.
go. That's where the package sits. Yeah, I was looking for that.
So yeah. So the first thing is where earlier I said the package goes into this area, right?
Right.
So now I'm looking for you to be able to translate that ISO view to this view, and then it's maybe a little hard to see, but yeah, you can see the lines
Right.
are pointing out the size of the opening. So
12.6.
and then the package itself is a little bit smaller than this opening size, right?
Yeah, 21.
Right. So it's got to fit. Yeah. So it was 12.5 by 20.9. So
Right.
can't be line to line. Plus you have the tolerance.
Yeah.
They have to worry about it. So if you notice, the tolerance is 0.15. We adjust here, note 3. We assume a 0.05 tolerance, not a 0.15 tolerance.
Okay.
Because otherwise, 0.15, right? That's half the ball diameter.
Oh, yeah.
Right. So those are the things that you'll be looking at, right?
Right.
So it's like, okay, with not only does the diameter matter, or the nominal value matters, but the tolerance matters more.
Yeah.
Right. Because it's how much do we have to, or do we have to adjust, do we have to reduce the tolerances for our design? Like I said, plus or minus 0.15 is, that's the whole diameter. If you look at the entire ball diameter,
Right.
if you take the plus and the minus side, but from that perspective, okay.
I see. Right. True.
So now find me the I guess. Oops, sorry. Tell me the dimensions related to package ball and the ball array. Can you pick those out here?
From this one?
Yeah. Tell me, is it top view, bottom view, detail view? So we're looking for pitch and we're looking for ball diameter and
Probably the top one. But...
Okay. All right. So we're looking at something that has the array, right?
Yeah, either
right.
the top or the bottom.
Shown. So it's either that. Yeah. Okay. You remember the values of the pitch?
Yeah, I want to say I see like 0.65 at
Mm-hmm. Okay.
Hmm.
You've got the 0.65 here.
Yeah.
You've got the 0.65 here.
Yeah.
Yeah. Okay. Right. And then the other thing we do is we actually have to dimension, we have to know the dimensions from here to here and from here to here.
Right.
But that's just math, right? 0.65 times the number of pitches, right? Okay, so you'll find that. You'll find those numbers here as well on the top view, right? A little easier when you can zoom in and see the dimensions, right? Where the lines are pointing, from here to here, and then from here to here, coming down here to the 11.05.
11.05. Yep.
Yeah, and it's almost always tied with the pitch. You see the line is both the arrows are pointing to the same line, both the pitch line and the end to end. So that's just another, key that they're tied together, right? They're referencing off the same line.
Right.
And then before we talked about the ball, right? So a little easier to find because it tells you ball diameter.
Yeah. 0.30.
Right, and then the ball height, and we care about the substrate thickness and so on. So you can kind of see the pins here. This is them in rest position. When you mount it to the PCB, the pins will push up.
Oh yes.
From here, and they'll go away. And then when you push the package down, so you're changing the height by 0.4 millimeters. Okay, so how much compression or how much distance does the pin travel from the top side? So you're going to have to do a little bit of math.
Yeah, I got to subtract some stuff. Hold on, let's see.
Okay.
Huh.
So you've got
the 0.13.
Right, that's how much, but I'm looking for the compression from the top side. The 0.3 is the compression from the bottom side.
Oh, okay. I had to take the 0.2 and minus 1.5.
No. So let me give you a little trick. So this is the pin length.
Oh, okay. 3.8 minus the 3.4.
Okay, and then minus what?
The 3.4.
Well, the 3.8 minus 3.4.
Yeah.
Right. So that's the rest length versus the test length. So how do you get just the compression from the top side?
Yeah, so 3.8 minus 3.4, and then minus the 0.05.
Well, I'm looking for the compression from the top side. So which 0.05 are you looking for? Are you telling me? Are you telling me this one or this one?
Oh, right? It's the 0.20 then.
Well, this is a relief cut, right? These are both clearance and relief cut, right? They're not actual pin dimensions.
Oh.
Okay. All right. So the 3.8 minus the 3.4 gives you 0.4 millimeters of total compression. Okay. And then minus 0.3. Yeah. There you go. No problem. No, I didn't necessarily expect you to, understand the drawing completely, right? And function. Just was looking to see. So yes, it was a 3.8 minus 3.4 minus the 0.13, which is the bottom side, right? That's the amount of compression from the bottom side.
Right.
Okay. So it gives you the 0.27.
Okay.
For the top side compression. All of that is something we normally will deal with on a day, these are things that it'll be little things that'll be off the top of your head, right?
I see.
What else is there? I mean, most of the stuff we have standards for. You just have to, make sure the value makes sense,
Mm-hmm.
right? We have design rules for how wide different things are, or where, the spacing. If the customer doesn't have a predefined layout that they want us to match, we have some predefined standards and so on. So there's a lot of that.
Okay.
So this is kind of the footprint that we give to the customers.
Mm-hmm.
Defines the area for the socket, plus also the area for the lid.
Mm-hmm.
If you remember, the lid is the actuator that pushes.
Oh, okay.
It mounts to the top of the socket.
Mm-hmm.
And its job is to push the package down to the test position.
Oh, okay.
Okay. This particular lid also has a heat sink built into it to make contact to that die that we were showing. Okay. Did I ask you before what's your thermal knowledge? Have you done a lot with thermal?
Yeah, done some heat sinks and thermal requirements, so kind of just basics.
Okay, all right, yeah. So standard fin heat sink that I see on the server board. So you're providing the input and that's needed for that particular chip or something.
Okay.
All right. So this shows the lid in its closed position. We do some more math. For example, this 3.43 number here. There's a depth of the socket, being 4 millimeters, and then we subtract the depth of the lid, and that should be equal to the package thickness.
Oh, okay, 0.57.
Yeah. So 0.57 plus 3.43 equals 4. Yeah.
Right.
Then there's the die thickness, and then that adds with this number, right? So this number is the surface area that this pushes on the perimeter of the package.
Okay.
Which has a certain thickness defined, which we can. A lot of times the customer will define it. Otherwise, we're just doing math. Right, to figure out what it is, what the layer stack is, and then the same thing with the die. You have the height of the die here, and then we have the offset here, the 0.99, which is the distance from the piece that pushes on the package body to the heatsink that pushes on the die. So it's a height difference. Okay. And then this would be the lid opening, So all of these dimensions get translated to the footprint. You can see that the lid is bigger than the overall socket, and it clamshells open. So
clamshell.
So it clamshells open. Right? So we have to give the customer all the dimensions. So they see make sure it doesn't interfere with their board.
Right. There's enough space.
Okay. Alrighty. Well, we're coming up on 11.
Yeah, good stuff.
11 already. So, all right. Any last minute questions, comments?
Yeah, whatever the next step, when I'll meet you or one of my team members.
How soon do you think you need to?
Yeah, I can kind of come out Friday this week or Thursday or Thursday.
Okay. There's that.
Next week.
Yeah. I mean, I may do it. I'll probably have you talk to my guys next week when I'm traveling.
Okay, cool.
Let me look at Thursday and see if it makes sense to just come over so you can put your hands on stuff, or I may wait till after. Okay. So I guess my question to you is how soon are you looking to change jobs?
Yeah, within 2 weeks or a week. week and a half, 2 weeks.
Okay, so you want to make a decision within a week and a half or 2 weeks, or you're just okay? So you have something else that you're looking at, or
Yeah, I can make a decision by this Friday.
okay? Well, I guess that's not what I'm asking for. I guess I'm how soon do you want to make the move, right?
Oh,
I mean, just part of because I'm asking. Smiths can be a little slow.
oh, okay.
So
Yeah.
so what's your sense of urgency for leaving Cisco and coming over to Smith? I mean,
Oh, okay. Yeah, I'm
do you
open.
need
No rush.
okay, so no rush, no okay, yeah. I mean, part of it is are you entertaining offers from somebody else, or are you looking at other companies,
Oh,
that kind of a thing. Not that I'm not trying to postpone things. I'm just want to get a sense of urgency from you.
sure,
So
sure. Yeah, no,
okay,
there's no rush. I'm still
okay,
good.
all right, sounds good. All right, okay, all right, sounds good. If you think of anything, feel free to reach out to me. I think you should have my cell phone number. So let me get with Jay. I'll talk to I'll have him set up some things with my guys for next week. I'll get back to you. Not sure I can do something this week, but I'll look at my schedule for Thursday.
Okay.
Would it be Thursday morning, like first thing?
Yeah, I'm open to that. If we have to
Same
do
kind of
it.
thing. I mean, I'm assuming your schedule would be same. Like we would meet at like 10 a.m.
Sure, sure. Thursday and
And
Friday, I'm pretty open. So usually
okay,
beginning of the week, it's a little bit more packed. But
got
like
it.
Thursday,
All right,
Friday,
all
I'm
right.
flexible. We can meet
Okay, all
mornings,
right.
afternoon, evenings.
Okay. Yeah, Thursday morning would be better for me if I could,
Okay.
if it works out at all this week. Okay.
Yeah, sounds like a plan. Thank you so much, Jim, for this
All right,
opportunity.
sure, no problem. Thank you.
We'll talk soon.
All right,
You have a good day.
talk to you. You too. Bye.
Bấm cái chữ escape đi.